Okay, so welcome to the last paper discussion of your IIT preparation. Okay, and you have already given this exam, so this is the last paper discussion from my side also. Okay, it has been a wonderful time with you people, 2.5 years to be precise, and we have gone through so many paper discussions, I think. So this is the end of it. Okay, after that you will be giving the final exam, and you know after that you'll be free from all these things. So let us begin our last paper discussion, and then we'll talk about other stuff. Okay, so let us start with question number 19, 20, 21. Any doubts in this?
19.
19 itself. Now you see here we have to actually see those ions which form amphoteric hydroxides. Okay, so if you are putting OH minus, then you'll be getting the hydroxides. But some of these hydroxides will be dissolving in excess of NaOH. Those will be amphoteric hydroxides. So in this case, if you see, Al3 plus SN2 plus Zn2 plus Pv2 plus, all these will be form amphoteric hydroxides. Now, it is saying that where we can separate the ions using excess NaOH. Means one of the ions should be dissolving, other should not dissolve. So copper 2 plus will not form amphoteric, it will form basic hydroxides. So B is the answer. Zinc 2 plus will dissolve, copper 2 plus won't dissolve. Okay.
Okay, sir.
Yeah. After this, next 21, 22. These are easy questions. 21, 22.
20 option B.
Option B. Lower alcohols are soluble in water because that is a correct statement, like CH3OH, C2H5OH. Okay. These will be highly soluble in water because the size of non-polar group is small. Okay. So in that case, what will and they will be forming hydrogen bonding with water molecules. As the size of the non-polar group or the hydrocarbon group increases, the extent of hydrogen bonding will be decreasing because the polar groups will repel each other. Okay, and it will prevent formation of what large number of hydrogen bonding with the alcohol molecule. So in that case, the solubility will be decreasing. So B is correct.
Okay, sir.
Okay, after this 22. Okay. 23, 24.
23, sir.
Okay, 23, all options. See, in 23, first you have to balance the equation. So if you balance the equation, you'll get that you'll have 5 Br minus and 1 BrO3 minus. Okay. Do you want me to balance the equation? Or can you balance it?
Sir, like option C, if pH is like double, then H ka concentration will be like 10 power minus 4, then why will the rate be doubled? Like power 4, sir, like into 4, sir.
Okay, let me just do this question. Okay, so uh, 23. Okay, so BrO3 minus is going to Br2. So plus 5 is going to 0. So it is taking 10 electrons. And Br minus is also going to Br2. 2 electrons. We have to multiply this by 5 and add it up. So basically you'll be getting 6 Br2 here. And you'll be getting 2 BrO3 minus plus 10 Br2. Sorry, 10 Br minus. Now, this is what you call as an electron balanced equation. Okay, you can also write it as BrO3 minus plus 5 Br minus giving 3 Br2. Now, if you balance charge, the total charge is 6 minus. Okay, and assuming that you are taking acidic medium, so you write 6H plus here and 3H2 over here. And this is totally balanced now. Okay. Now, if you are writing rate, the rate expression is given. Okay, it's H plus square. Now, if the pH of the solution is double, pH of the solution is double means that rate of consumption of BrO3 minus will increase by a factor of 4. Actually, it should be concentration of H plus. Okay. So C is not a correct option. Getting my point?
Yeah, sure.
Okay. So the rate of consumption of BrO3 minus will also be the rate of reaction as per this equation. Okay, rate of reaction is the rate of decomposition of BrO3 minus by stoichiometric coefficient, which is 1. Okay. And D is not correct because the stoichiometric coefficients are missing. Are you getting a point? So answer should be A and B only in this case. Is it clear?
Yes, sir.
Okay. 24. 24.
Sir, 24
Doubt, sir.
option.
24, which option?
B.
B for Bombay.
Yes, sir.
That's good. Okay. Based on our above titration curve, the ionization constant of HA is 10 to the power 1 minute 4.89. Okay. Means pK is 4.89. So that we have to see. There's a pH at 0 is 2.86. Okay. And at half neutralization, if you see, so this is like 15 ml and this is 30 ml. So this is the point of half neutralization. Okay. So at half neutralization, pH is equal to pK. I think I've given this point. So pH is 4.89, so pK is also 4.89. So K is 10 power minus 4.89. Are you getting a point? Yes or no?
Why is it like that, sir?
Why it is like this? You are asking this?
Yes, sir.
Okay, you see, what happens is that suppose I'm having HA plus OH minus, giving A minus plus H2. Okay. Suppose initially I started with A moles. At half neutralization, how many millimoles of OH minus I would have put? A by 2. This is 0, 0. So finally, I will be left with A 0, A by 2, and H2. Now, between HA and A minus, there will always be this relation, H plus plus A minus. Okay, so at equilibrium, if you are having A by 2 of this and A by 2 of this, then I can write pH as pK plus log of A minus
Okay, sir, understood.
HA. Okay, so this is A by 2, this is all A by 2. So pH is equal to pK. Okay. 24 is, I guess, done. Any other doubts in 24? We'll make it a bit smaller so that you can see the whole question. Is it good, 24? There's nothing in this question which you can't do. Okay, moving forward. 25, 26, 27, 28. Twenty-five, 26, 27, 28. So what are you?
26.
Huh? 26.
Yes,
Okay,
sir.
yeah, 26 is something which they ask all the time. Okay, so this is based on Pauling's electronegativity formula. Okay, which says that, XA minus XV means electronegativity difference will be equal to 0.208 under root of delta. Okay, where delta is equal to D of AB, bond energy of AB, minus either arithmetic mean or geometric mean. Okay, so mostly arithmetic mean is taken, so bond energy of AA plus bond energy of BB by 2. Okay, so if we use this, you will get the answer. This is Pauline's electronegativity formula, which is an empirical equation to decide the electronegativities. Okay, Pauling took electronegativity of hydrogen to be reference as 2.1, and with respect to that and using this formula, he calculated the electronegativities of other elements. Okay, so if you use this
Okay,
formula,
sir.
okay, there's nothing in this question which is, and I don't expect it to come in ITJ because it's an empirical formula based thing. They will never ask. Okay, because there are a lot of empirical formulas. I think Mulliken's formula is also there, and that's why I told you people it's not required when I was teaching you. Okay, but in test series they will be asking these type of questions. Okay, 26, 27, 28. I think these are easy questions. Okay. 29, 30, 31. 29, 30, 31.
29, sir.
Okay. 29 actually looks scary, but it's not that tough a question actually. So I just tried this and it's easier. Okay, although the solution which they have given is not good. Okay, but if you just use your basics, you will be able to do it. You see, it's not given that what is the initial concentrations of A, B, but they have given equilibrium concentrations as 0.5, 3, and 1.5. It is giving that at start of the reaction, C is absent, when C is 0, but D is 0.5. Okay, so let us say that initially A was A and B was B moles. Okay, then at equilibrium, it will be A minus 2x, B minus x, x, and 0.5 plus 3x. Now here, from this you will be getting like three equations. A minus 2x is equal to 0.5, B minus x is equal to 3, x is equal to 1.5, and D is 0.5 plus 3x. Now x is 1.5 and B minus x is 3 will give you B, and A minus 2x is equal to 0.5. You can use x to get A. So A will be 3.5 and B will be 4.5. And once you know x, you can also find the equilibrium concentration of D, which will be 5. Okay, so from this you can find Kc. Kc will be coming out to be something like 250. Concentration of A plus B plus C plus D will come out at equilibrium will be 3.5 plus 4.5. Sorry, 0.5 plus 3 plus 1.5 plus 5. That will be 10. So Kc by sigma A at equilibrium is equal to 25. Are you getting a point?
Yes, sir.
Okay. If you do it, you will be getting it. The only thing is, if you start thinking without writing the equation, you won't get this question. Okay, you assume the variables which you think are there, and then you try to solve it, you'll get the answer. Okay. 30, 31, 32.
31.
31, it is an equilibrium reaction, so delta G will be 0. Are you getting the point? No calculations are required.
Then why did they give all those values, sir?
Just to confuse you people.
Okay.
Okay. If they would have given standard gas-free energy change, then these values would be used. Okay. But they have not given that. Delta G not for the reaction. That will require the values of delta X1, X, Y, and Z. But they have not given that. They have given delta G. So delta G for an equilibrium is always 0. After 31, 32 is it out? Yes, no. Is 32 a doubt? Okay. 33, 34, 35, 36.
36, sir.
D and E are related as metamoles. Okay, let us do this question. 2-butanol is something like this. Okay, when you're doing PCC, this doing NH2OH, this, then you are doing PCl5. Okay, B plus C. Okay. So here you can get OH on this side, plus you can also get OH on this side. Okay. Now if you're treating it with PCl5, Okay, you see and what will happen is that first you'll be getting OPCl4 and HCl, and then this will be migrating like this, and this will be going out. Okay, so you are remembering the Beckmann's rearrangement? Yes or no? First, you will be getting this OPCl4. Okay, and then CH3 migrates with this lone pair, and this goes out. So you'll be getting N double bond C with a positive charge and CH3. Okay, and then H2O, if will attack here, you'll be getting CH3 and double bond COH, C2H5. And this will again tautomerize to give CH3, NH, C double bond O, C2H5. Okay, if you do the same with this, okay, what will happen? Instead of CH3, it is a C2, anti-group is C2H5. So this will be migrating here. Okay, and you will be getting CH3 and H, sorry, C2H5 and H, because C2H5 is going there. C2H5 NH CO CH3. So if you take this group to be the functional group, then it is linked through two different terminals. So these are metamers. Are you getting my point? Yes or no?
Yes, sir.
Okay, after this, any other doubt? This paper is done? Yes or no? This paper is good. Okay, it's neither easy nor tough. Okay. But I feel that it's not that lengthy also. It's a good paper. Okay, so after this, let us move to the next paper, which is before Rajesh calls. Okay, let us try to finish it. I think he must be sleeping right now. So 19th, 2021 is paper 2 now. 19, 2021. '22. Always remember, for square planar complex, you need a D9 configuration. Sorry, D8 configuration. '23, '24. Bhanu sir has given a lot of instructions. In any case, to get below 10,000 rank, below 5,000 rank, below 3,000 rank. Okay, that is good, but it is very tough actually. Take only curd rice. This is a good thing. Are you taking curd rice on the day of exam? Dean's assessment. Okay, it's not Bhanu's assessment. 5:30 p.m. you can eat whatever you want. Okay, if parents permit. That also parents have to permit. Tough life. Okay, 23, 24, I guess there's no doubt because you were silent. 25. Here they are just asking about soluble hydroxides. So most of these hydroxides will be water soluble, except ALOH whole thrice. But I think even MgOH whole twice should also be water insoluble. Let me just check once. MgOH whole twice is insoluble in bases. MgOH whole twice is actually having low solubility. Okay, and then so they react with each other, forming salts that are soluble. BOH whole twice, only MgOH whole twice remains in the solid. Also dissolves. Okay. The logic is that if you are dissolving this, you'll get a strongly basic solution. So, okay, so these four will be creating a strongly basic solution. Okay, which will be dissolving this to BOH whole 4 2 minus, this into ALOH whole 4 minus, this into SNOH whole 4 2 minus, this into ZnOH whole 4 2 minus. Okay, and SROH whole twice is also water soluble. Only MgOH whole twice won't be. This is the answer. That's what that. MgOH whole twice is insoluble in water as well as strong bases. So that is why. Okay. Are you getting this question? 25?
Yes, sir.
Okay. 26, 27, 28.
Sir, 28.
28. How many of them are isomers of benzene? You see two things. Du should be equal to 4 and number of carbons should be equal to 6. Okay. So this is not having 6 carbons. This is not having 6 carbons. So these two are gone like this. Okay. So, and du should be 4. So this is having du3. This is having 4. Okay, 3 double bonds plus 1 ring. So this is an answer. Okay, then this is having like 4. So this is an answer. This is having 4 du. So this is an answer. This is having 3 double bonds and a ring. So this is an answer. 3 rings, this is an answer, this is an answer, and this is an answer. So answer is 7. Are you getting a point? Yes or no?
Yes, sir.
Okay. 29.
26.
What, 29? Your voice is not audible clearly.
Sir,
26.
29.
27 is also dog?
29, sir.
29. Okay. More reactive than ethane towards electrophilic addition. It should not be ethane actually, it should be ethene actually. Ethane does not undergo electrophilic addition. If it is ethene, then you can do this question. So more reactive. Now you see if okay, you are having a group which is electron withdrawing. Okay. See, in electrophilic addition, what we do? Suppose we generally add HCl. So first the attack of electrophile takes place. So you get GCH, CH3 plus. So if G is electron withdrawing, it will destabilize the whole carbocation, which is the intermediate. It will slow down the reaction. If G is electron donating, then the carbocation is stable. So rate of reaction is more. So we have to look for the electron donating groups. This is an answer. Okay. This is an answer because this is also an answer. This is an answer. Answer should be 4. Okay. 1 minute, let me check what are the answers. 1, 4, 6, and 1, 4, 6. Okay, they have not considered this. Yeah. They have considered this one. Okay, this is not considered because overall, if for this minus I will be greater than plus m. Okay, as we know in the activating deactivating effect on benzene. Okay, and this will be done because you see overall this pi bond can donate the electrons and stabilize the positive charge here. So these 4 are the answers: 1, 4, 6, and 7. Is it clear?
Yes, sir.
Okay. So after this 30, 31, 32.
So 26.
Okay, you see there are two endpoints which you got at 30.4 and 15.6. This means that it is, you see, generally if it is having only 2 acidic hydrogens, then the what you say as endpoints will be equally distanced. Okay, this means should have been 30.4 and 60.8. But here it is not like this. 30.4, 45.6. This means what is the SCF? It is 15.2. Okay, this means it is having 3 endpoints: endpoint 1, endpoint 2, and endpoint 3. Okay, so if it is a 3 endpoint thing, this means it is having 3 acidic hydrogens. Means it is HVO3 whole thrice. Are you getting a point?
No, sir.
You see, you are having a 30.4 and 45.6. Suppose I am talking about H2CO3. Okay, if I say that the first endpoint is at 30, what will be the position of second endpoint? Can you tell?
Don't know, sir.
Okay, H2CO3 OH minus SCO3 minus OH minus CO3 2 minus. Okay, so suppose I am starting with 0.1 molar and 30 ml. Okay, so total I am having 3 MEQs of this, and I am adding 0.1 molar OH minus and 30 ml. So what will be the first reaction which will be taking place? H2CO3 plus OH minus giving SCO3 minus plus H2. So initially I'm having 3 MEQs of this, 3 MEQs of this, 0, 0. Okay, so at the end you will be getting 3 MEQs of this. This will again react, okay, with OH minus. So this will, if you are having this of 3, then how many milliequivalents of OH minus you will consume? 3 only. Are you getting my point? To give this reaction. Yes or no?
Yes, sir.
So you see, if it is a diprotic acid, then both endpoints will consume equal amount of base. Okay, but you see, it's not a diprotic acid because second endpoint is consuming 30.4, third is not consuming 60.8. It is consuming only 45.6. This means it is not a diprotic acid. It has to be a, more than di. So if you take the HCF, then you see 15.2 will come. So this means that it is having like 3 endpoints, first, second, and third. So you see, for reaching first endpoint, between first and second, you are having equal volume or equal milliequivalents of base, and between second and third also equal milliequivalents of base is consumed. So it is a triprotic acid. Are you getting my point?
Yes, sir. But like, how do you know it won't go more than 45.6?
Because they have mentioned that much only. Based on the given data, we can only conclude this much.
Okay.
Okay. So HPO3 whole 3 will be looking something like this. I guess you people know how to draw. So anyone going outside for vacation or something like that? Something like this. Actually, it should not be like this because that will be going, it won't be a linear chain, I guess. It should be a cyclic chain. P O P O P O. This is double bond OH, double bond OH, double bond OH. Yeah, this is better. 30, 31, 32. No doubts.
30.
Calculate the change in pressure on 2 moles of NO and 16 grams of O2. So best way is to convert everything into moles, NO plus O2. You have initially 2 moles of NO and 0.5 moles of O2. In a 6.25 liter container, that is very good. And you are getting NO2. Okay. And you are getting half of the maximum quantity of NO2 possible. So you see, if the reaction is fully done, then this is the limiting reagent. Okay, 2NO plus O2 giving 2NO2. This is the balanced equation. So still the limiting reagent is oxygen only, so it will get completely consumed. Okay, if 0.5 moles of this is done, this will be 1 mole of this will go, and you'll be ultimately getting 1 mole of NO2. Now this is the final if full reaction is done. I am getting only half of the product. So for 0.5, okay, only 0.25 of this will be gone. So you'll be still living with 0.25, and this you'll be having will be 1.5. Are you getting a point? Yes, no. It is saying that you are only getting half of the maximum quantity. Maximum I am getting is 1 mole of NO2. So half of that will be 0.5. Are you getting a point?
Yes, sir.
For getting 0.5, these will be the remaining reactants. Once you know this, you can find the total number of moles at equilibrium. Okay. So N total is 1.75 and 2.25. Okay. So what is delta N? Delta N is equal to 2.5 minus 2.25. This is 0.25. So delta P is equal to delta nRT by V. Delta N is 0.25, okay, by 6.25 into R is 1 by 12 into T is 300. So it's like 6.25 by 625 by 6.25 by 6.25. So it is equal to 1. Are you getting a point?
Yes, sir.
That's good. Okay, apart from this, any other doubt in 31, 32? In 33, option D should be S only. Group 2 bicarbonates do not exist in solid state. So T cannot be answered for magnesium bicarbonate. Group 2 bicarbonates and lithium bicarbonate. Okay, they don't exist in solid state. Are you getting a point? So in T, T won't be an option. Is it clear? Yes or no? Thirty-three is clear. Yes, no. No doubts from 30 to 33. Okay, moving forward. 34, 35. First 34. 35, in 35, I don't think SnCl2, which is the Stefan's reduction, is used anywhere. It is generally used for nitrogenous groups. So I think Q should not be there anywhere in the options. Others will be there. Okay, 36. 36, all are cubic unit cells, so all will be having similar type of features. Okay. So P, Q, R, S, T, all are correct for each of the options. Okay, so I think with this, if you don't have any doubts, then we can conclude this session. It is 8:58 already. Okay, I won't take too much of your time. Okay, so the paper discussion, the final paper discussion, the last paper discussion is over now. Okay, now tomorrow I think you people are going for the exam. Okay, now you see, there's nothing which I can say which can, prepare you for what you're going to face tomorrow. Okay, although we have done a lot of preparation, lot of tests. Okay, but there's a, like a mental point of handling whatever you're going to face tomorrow. Okay, because questions will be new. Okay, but remember one thing, have faith in whatever you have prepared for the last 2.5 years. Okay. And second important thing is that you have prepared enough. That is what my verdict is. Okay, you are prepared enough. Only thing is that you have to have faith in yourself. That is the most important point which, you'll be taking forward when you go to the exam hall. Okay, have full confidence in yourself that even if any question, and have total, what you say, as faith on your concepts and your intuition. Okay, do not doubt yourself at that point of time. Even if you lose 1 or 2 questions, it's okay, but mostly you won't take that step. Okay, the important point is that if you feel that this is a process through which you should go to get you try that process. Do not think whether it will give you the result or not. Lot of time when you go to the approach, you will be getting answers, and this will be working very nicely in case of physical chemistry. Okay, just by looking at the question, you won't get a clue of what the answer is, but you go to the approach which you have developed for solving problems in physical chemistry, you will be able to do. The best way is to proceed. Seek the question at one go. Okay, things might not click. Okay, so you have to give it a bit of effort. Otherwise, you will feel that the whole paper is tough. Okay, generally, if the paper is tough for you, then it's tough for everyone. So in that case, your belief in your concepts are tested. Okay, whether you are ready to apply your concepts even in a situation where you are not able to figure the answer just by looking at the question. Okay, so try. So do not hesitate in trying. Okay, remember that in this paper, if you get 50% marks, you will be something close to 1500 rank. Okay, which was, under 1300 was my rank. If you get closer to it, you will definitely get a very good college, very good IIT at this rank point. Okay, because there are girls quota also. So the idea is that for taking 50%, scoring 50%, you don't have to do every question. Okay, but at the same time, you should not leave a question just because it is looking complicated. Okay, give it a try. Okay, you will get the answer. Okay, the key here is to struggle with the questions which you can do. Okay, so you should try, and I think every one of you will be doing good. Okay, and don't worry about what you did in the previous exams. or previous grand test or something like that. Tomorrow is going to be a new day, okay, and you people are fully prepared conceptually for that. Okay, I don't think there is anything which we have missed during last 2.5 years of preparation. Okay, whether it has been covered, just have full faith on your memory also. Whatever you will be recalling will be mostly correct. Okay, and do take rest. Okay, between the exams, try to take a nap of half an hour or 45 minutes if it is possible. Okay, keep someone with you so that you don't have to do not go alone to the center, because you might be needing some support during the break. Okay, but try to rest between the two exams. That is the most important thing. Your mind should be well rested before the second shift. Okay, even if the first shift was tough, okay, there will be a chance to recover in the second shift. Okay, so but only if you are having a rested and relaxed mind. Okay, so with this, I will be ending the paper discussion finally. Okay, go there, okay, with confidence and give your best attempt. Okay, rest we will see. No one is knowing who will get what rank. Okay, it is all depending on how you do, with what attitude you go tomorrow. Okay, have a fearless attitude, have full belief in your concepts, and you'll do good. Okay, thank you people from my side. It has been great pleasure to teach you for last 2.5 years. Okay, so it is you people have worked very hard. Okay, and I will be saying that till now you people are the best batch I have taught. Okay, thank you people. Okay, best of luck for tomorrow's exam. Okay, I'm ending this paper discussion now. Thank you.
Bye, sir.
Yeah. Okay, do tell me how the exam went after the exam is done. Okay, so I'm ending that paper discussion now. Okay, thank you. I will post this link on YouTube. Okay.